In October 1957, a beekeeper in Rio Claro, Sao Paulo state, noticed that 26 colonies had vanished from their screened hives. The colonies belonged to geneticist Warwick Kerr, who had imported queens from southern Africa the year before to cross with local European stock. Within weeks, the escaped bees had begun nesting in tree cavities and wall voids, and their descendants would prove far more difficult to contain than anyone had planned. The escape itself was ordinary, a set of screens left off during routine inspection, but the biological properties the bees carried turned that single lapse into a continental shift. This is Unintended Consequences, episode 78. Warwick E. Kerr, a Brazilian geneticist trained in the United States, wanted to improve honey production in the tropics. European honeybees, the standard commercial strain, reduced activity and stored less honey when temperatures and humidity rose above the thresholds the bees had evolved to handle in temperate climates. Kerr had read reports that the African subspecies Apies mellifera scutellata maintained steady foraging and brood rearing under those conditions, continuing to gather nectar and pollen on days when European colonies remained inside the hive. In 1956, he arranged for 173 queens to be brought from South Africa and Tanzania to an experimental apiary at the University of Sao Paulo's Luiz de Queiroz campus. The goal was straightforward: produce a hybrid that would give Brazilian beekeepers higher yields without requiring new equipment or management techniques. At the time, no one expected the hybrids to travel far or to change their defensive behavior so sharply once released, because the breeding work remained inside controlled yards and the economic payoff for local agriculture appeared immediate and contained. Kerr's team placed the African queens in isolated mating yards and allowed them to produce drones and daughter queens. By early 1957, the first hybrid colonies were being tested in field apiaries. Kerr reported increased honey stores compared with pure European lines, and local beekeepers expressed interest in trying the stock. The program remained small and research-oriented. The queens were kept behind queen excluders, grids sized to let workers pass but block the larger queen, and the hives were fitted with screens to prevent accidental swarming. Kerr himself later stated that he had planned further controlled crosses before wider distribution. In late 1957, an assistant removed the screens from 26 hives to inspect them and failed to replace the barriers promptly, allowing the colonies to depart as swarms. The decision to use screens rather than more permanent barriers reflected the assumption that the research setting itself supplied the necessary containment. The escaped swarms found abundant nesting sites in the Brazilian countryside and quickly established feral populations. Because African bees mate at greater distances and their drones outcompete European drones at congregation areas, the hybrid trait spread rapidly through successive generations. Within 5 years, the new bees had displaced or hybridized with most managed European colonies in southern Brazil. Their defensive response was markedly stronger. Colonies would pursue intruders for hundreds of meters and attack in greater numbers once the alarm pheromone threshold was crossed, a trait tied to the same genetic package that supported vigorous foraging. Between 1960 and 1980, Brazilian health records document several dozen human deaths and hundreds of livestock losses attributed to mass stings, though exact totals remain uncertain because reporting was inconsistent. The bees also proved vigorous foragers, pollinating crops and wild plants more effectively than the strains they replaced, which created a counterbalancing benefit that beekeepers in some regions learned to value even while they adapted to the added risk. By the late 1970s, the hybrid population had moved through Central America. The first colonies reached the United States near Hidalgo, Texas in 1990. Beekeepers in the southern states had to adopt heavier protective equipment and more frequent colony inspections, raising operating costs. The same reproductive advantages that made the bees successful also made them nearly impossible to eradicate once established outside managed apiaries, because any surviving swarm could restart the population without further human assistance. Public alarm produced the killer bee label in the press, but control efforts focused on practical management rather than eradication. In the United States, the Department of Agriculture established a barrier zone along the Mexican border using bait hives and drone trapping. The effort slowed, but did not stop northward movement. Beekeepers learned to requeen with European stock annually in some regions, though success varied because the hybrid drones continued to mate with new queens. In Brazil, many commercial operations simply switched to the hybrid bees and adjusted handling practices, accepting higher productivity alongside stricter safety protocols. Today, Africanized honeybees occupy most of South and Central America and the southern tier of the United States. Estimates suggest they account for the majority of feral colonies in those areas. No large-scale reversal has occurred, and researchers now treat containment as a permanent feature of tropical and subtropical beekeeping rather than a problem that can be solved after release. When an organism can reproduce and disperse on its own, the traits selected in the laboratory travel with it, and any failure of physical containment becomes permanent. Breeding programs that optimize a single performance metric must therefore treat escape prevention as a core design requirement rather than an afterthought, because ordinary human procedures and ordinary biological variation will eventually test every barrier. Modern gene drive and synthetic biology projects face the same constraint. Once released, living systems set their own boundaries. The question for any new release is not only whether the engineered trait performs as intended, but whether the mechanism for keeping that trait inside its intended range can survive ordinary human error and ordinary biological variation. We'll leave it there for today. Thanks for thinking through this one with me. If you know someone who loves a good cautionary tale, send it their way, and I'll see you tomorrow with another. And if you'd rather watch than listen, find us on YouTube at Nerra Network. Links in the show notes. This show comes to you from the Nerra Network. If you want another sharp daily briefing, OmniView has you covered, a balanced daily world news briefing that takes every side seriously. All our shows are free at nerranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at nerranetwork.com/data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.